Now there's a meteorologist in every single pilot, and that's just because the weather is very important for your flight. It's part of the flight preparation because it determines how efficient your flight's going to be, how safe your flight's going to be, and it just affects the way the aircraft performs and behaves. So looking at weather is very important prior to making your flight, and that's why flight planners like the Freeware ones, for example Rocket Route or Simbrief, or Professional Flight Planner X, which is a Payware one, often provide you with weather charts, and today we're going to take a look at those weather charts. So just to give you a basic idea, I will show you my way of how I look at the weather prior to making my VATSIM flights, and we'll also take a look at the weather charts that flight planners provide, like the significant weather charts, how to read them, and how to interpret them, because it's very interesting information, and you might wonder what all those symbols on those charts mean. But they do all have a meaning, and some of them are very important. So we're going to take a look at that. And so let's go ahead and take a look at those charts.
So here in front of us we have a basic weather chart. It's not necessarily an aviation weather chart, but this is just a simple chart that you can get at your National Weather Service. For example, here in the Netherlands, I got this one from there, and you can probably get these kind of charts there as well, or you can just view them in your flight plan. Okay, so we can see a lot of things here. We can see, these letters H and L. We can see these weird little lines here. We can see numbers. So what does this all mean? Now, let's first go into those H and L's. And of course, you may know they stand for high and low pressure systems. So let's start with a low pressure system. You can see one here. A low pressure system is usually associated with bad weather. And why is that? Well, in low pressure systems, the pressure is low, so it's usually less than 1013 hectopascals, or 22.92 inches of mercury, which are atmospheric pressure measurements that we use in aviation. So what does this mean? Well, it means that the air in this area is less dense. So what will happen, because the air is less dense, it will kind of rise up in this center area. Okay, so it will go from the ground up into the center of the low pressure system. Now, of course, when this air rises, at some point it will encounter colder air. As you may know, if you've ever been in the mountains, the air is cold at higher altitudes. So here is the same principle. At some point you will encounter colder air, or this warmer air of the low pressure system will condensate, and it will form clouds and all the associated weather phenomena that are associated. So like rain or snow, or just clouds in general. So you can see in low pressure systems, you kind of have to look out when you're an aviation simmer or pilot, because it's usually associated with bad weather. High pressure systems, on the other hand, are associated with good weather generally. Okay, you can see that here. You can see those lines. The closer the lines are together, by the way, the stronger the winds are. And you can also see the numbers here, like 1050, 1045. So in high pressure systems, we have a pressure higher than 1013 hectopascals, or higher than 22.92 inches of mercury. And we can see that in this case, that's true. Okay, so in the high pressure areas, the air is more dense. Okay, so what will happen, instead of the air rising, it will fall down to the ground and spread around a little bit. So, as the air falls away from the center, it's kind of more stable in these areas. Okay. Now we can see in this chart a lot of information about this. Okay, we can see quite a significant low pressure area here, and some high pressure area here above Russia, for example. And it coincides a lot with the wind and with the satellite images. Okay, now what happens in a low pressure system area in the northern hemisphere of the Earth? The wind or the air moves counterclockwise. So if we follow my pointer here, it will go this direction. Now, if we look at the satellite images, you can see that, if you just look a little bit west of Spain, right here, you can see this low pressure system move counterclockwise as we advance in time, using these satellite images. Same for this little low pressure area that you can see on the chart here. You can already kind of see it forming on the satellite images as well. So the air moves counterclockwise in the low pressure area in the northern hemisphere. If you live in the southern hemisphere, it's the other way around. High pressure areas, like the one right here, will move the air clockwise. Okay, so if we follow the pointer again, let's start here, for example, the air will kind of move this way. Okay, and again, we can see that kind of in the satellite images. In high pressure air, it's a bit more difficult to see, but you know, you get the idea. Okay, so the next things are fronts, and those are those little peculiar symbols that we see here. Okay, so what do they mean? Let's go over them quickly. Now, a front basically means when you cross it, there is going to be a change of weather generally. Okay, so you have to, you know, kind of take that into consideration when you fly, that if you cross such a front based on the weather prognosis charts, you can kind of imagine that you will enter different weather than where you departed from. Okay, so cold fronts like here are displayed with this blue line, and the triangles point towards the direction to which the front is moving. So in this case, it goes from this direction to this direction. So it means colder air is coming in. It usually is associated with higher wind speeds and some other weather, but it's not really important. You just have to remember that the weather will change and it will get colder, of course. Now, warm fronts like this one, indicated by the red line with the half circles. Again, the half circles point in the direction to which the air or the front is moving. Here, warmer air is coming in. Okay, and it usually is associated with clearing of weather, and if the warm air stays in position a little bit, there's a likely chance of thunderstorms developing. Now, occluded fronts, which are these purple ones, okay, are kind of when a cold front overtakes a warm front. So you can see, blue with red makes purple. So you can kind of see where they got that color from. And occluded front, so it means that the cold front overtakes the warm front and is associated with thunderstorms and other, events of weather, depending on the air temperature behind that front. So again, here the purple line indicates an occluded front, and the symbols point in the direction at which the front moves. Now, if we go back to our little chart here again, we can see a lot of fronts. Like in this low pressure system, we can see that, a front's being pushed out, an occluded front in this way. We can see another occluded one here and here above Europe. We can also see a warm front here, and then we also have another one, which is a stationary front. And a stationary front is basically when the front doesn't move at all. So you kind of have one symbol pointing to the left, one symbol pointing to the right. Okay, and again, you can see the stationary front here. So here, the weather, the front doesn't really move, so it's usually associated with a lot of rain in the area, because the rain will just stay in place without the air really moving in any kind of direction. So you can kind of get an idea what these fronts mean on a basic weather chart. So let's go into the aviation weather charts. I think it's important as a simmer or even a real world pilot. I think they do that in real life. They look at the basic weather, like the basic weather charts. But once you get it into the cockpit and at the airport, you will be presented with true aviation charts. So let's take a look. Now, first of all, wind charts. Probably, the most important one. Well, probably. It tells you a lot about the efficiency of flight, okay? If you have a lot of headwind, of course you will burn a lot more fuel. So let's take a look. Actually, it's pretty easy, okay? The symbols just indicate a lot. You kind of have to see this as a little flag, all right? And the direction of the wind is it goes from the top of the flag to the bottom of the flag, kind of. You kind of get the idea. This is just from the legend of a rocket route flight plan associated with the chart, okay? So in this case, the wind moves from the top to the bottom of the little flag. Okay, so it moves from left to right. And then you have the symbols on the flags. You have a little stick here, indicate 5 knots. You have the larger stick here, indicating 10 knots. And you have the triangle indicating 50 knots. Now on the weather chart, you will see multiple of these symbols in one flag, and you just have to add them together. So for example, 2 triangles makes 50 knots. 1 triangle one large stick and one small stick makes 50 plus 10 plus 5 is 65 knots. Okay, so if we take a look at the weather chart here, we can see that, right? We have, for example, this one. We can see that this little wind flag indicates that the wind is moving from this direction to this direction with a speed of 50 plus 10 plus 10 makes 70 knots. Another flag here, for example, indicates a speed of 50 plus 5 is 55 knots. Now, as you can see, you kind of get a general idea about the direction of the wind. So you can kind of draw an arrow right here to see for this flight, which is going from Amsterdam to Bratislava. So you're going to fly from the west to the east. You can see that the wind direction is roughly similar to the route, which indicates that we'll have some nice tailwind right here. Now here's another example of a wind chart, and this is a flight from Vágar in the Faroe Islands to Keflavik Airport in Iceland. And as you can see, it's a bit different, right? We can see, wind vanes in different directions and at smaller speeds. For example, only 5 knots, only 10 knots. So that's not a lot. So we can draw those arrows again, and we can see that the air moves counterclockwise. Now, where have we seen this before? That's right, in low pressure systems, right? We can see a low pressure system here. Now, please do note that these charts are, that are provided by your flight planner might be a little bit of a time difference in between them. Like this one is from 6 o'clock, while this one is from 12 o'clock at night from that day. So you can see by the time 6 hours later, this pressure system probably has moved a bit more towards Iceland. And then we can see that, from the wind direction, you can already kind of see what kind of pressure system will be, in your area. So the wind moves counterclockwise, and then, you can already anticipate, okay, there's a low pressure system area here because air in the low pressure system will move counterclockwise. Now, if this would be a map in Australia, let's just pretend that this is Australia. This actually would be a high pressure system because then it works the other way around. Then if the air moves counterclockwise, it would be a high pressure system. But for now, let's focus on the northern hemisphere to make things easier to prevent confusion. But if you live on the southern hemisphere, just you have to turn everything around that I said. Okay, so counterclockwise, low pressure, clockwise will be a high pressure area. So you can see, for example, here is a high pressure area, and here's a low pressure area. So the wind moves here in this direction, and the wind around this high pressure area will move in this direction. You can kind of see that, the wind kind of moves in this direction in between those low and high pressure areas. You can easily draw that here the same. Okay, wind will move around here from the high pressure, and wind will move around here from the left pressure. Again, creating this wind movement right here. Okay, so that's the basic idea of the wind. Now, of course, at altitude, the winds will be higher in general. Okay, so you have to take that into account. This is a weather chart provided by a rocket route flight plan. And, we can easily see that the winds are very high, for example, here at flight level 340. So in some cases, it might be more efficient to fly at a higher flight level, even though you have to burn more fuel getting there. If you're going to have a lot of tailwind at that flight level, then it might be more beneficial. Or if you have a lot of headwind at a certain flight level, you might want to keep at a lower flight level or climb at a higher flight level where you have less headwind, because you don't want to run out of fuel once you get close to your arrival airport. Okay, so it's very important to realize the direction of wind and the strength of wind when planning your flight. But usually the flight planner will do a good job at fuel calculating. So next up are the most, I think, interesting charts, the significant weather charts, and they indicate a lot and are very important because they will indicate areas where you have a lot of wind and where it might be dangerous to fly. So let's take a look. So here's the basic significant weather chart. As you can see, we see a lot of things. We can see text. We can see numbers again. We can see these large arrows and all kinds of little cloudy areas, as it seems. So let's take a look. As with any chart in aviation, you just have to look from the bottom or from the top to the bottom, right? So you can see, it's issued by blah blah blah. It runs from flight level 100 to flight level 450. It's valid at 6 UTC on the 4th of January 2015. And yeah, you kind of have to know the times of your chart, what levels it displays. Okay, so you kind of get an idea of what you're looking at. Okay, so here are some of the most important symbols that you will see on a significant weather chart. I think those four right here are the most important. The moderate turbulence, severe turbulence, the moderate icing and severe icing, and these are some other symbols that you might encounter, but which are not really of importance right now. Okay, so if we look at the chart, we can see a lot of things, and let's first take a look at this large arrow, and this arrow indicates a jet stream, and a jet stream is made use of when flying transatlantic flights, for example. You want to make as much use of this jet stream when flying from the west to the east, so you get a lot of tailwind, so your flight is more quicker and efficient. And of course, you want to avoid the jet stream when you're flying from the east to the west, because otherwise you're going to be flying a lot of headwind and you might have a lot of turbulence, for example. So these large arrows indicate at what flight level the jet stream is located approximately and what the speed is. So in this case, this jet stream over here is at flight level 370 with a speed of 50 plus 10 plus 10 plus 10 plus 10 is 90 knots. And right here is a bit faster, even like 110 knots. And here is even more fast, 130 knots. And here it dies down a little bit again. Okay, so you can see the altitude and speed of the jet stream. Now, next up is the significant weather areas. Of course, that's where a high-level significant weather chart is for. So we can see here isolated embedded cumulonimbus clouds. Okay, so we can see also in the description I've included a link to the document that tells you a lot about these charts, but this one is what you most frequently see. It means that there are cumulonimbus clouds, which are thunderstorm clouds basically, in this area with the top height, the top level of flight level 350. So above flight level 350 you won't enter those clouds, but once you get below flight level 350 you will be flying in those clouds. And the XXX means that it's below the bottom limit of those clouds, is below what the weather chart actually is able to prognose. Okay, so our chart was running from flight level 100 to flight level 450. So this means that these clouds are somewhere in between flight level 350 and some altitude lower than flight level 100. Okay, same with these icing areas. Okay, we can see here moderate turbulence and icing, and this icing conditions in this area are running from flight level 160 from the bottom up, somewhere below flight level 100 to flight level 160. Same for the icing. For example, here it runs from some level below flight level 100 to flight level 120. Okay, so these charts are, or these areas are very important to take into consideration, because as you cross those areas, you might want to adjust your flight level, or in case of the cumulonimbus, isolated, embedded, it means that those clouds are embedded within other clouds, and that there may also be isolated cumulonimbus clouds. And this, is important because you might want to turn your weather radar on here to avoid clouds if you're flying somewhere in between these flight levels, or if you're flying to an airport, which is within this area. Okay. So if we go back to our chart, we can see a lot of things. Here over the Atlantic Ocean, we have this isolated embedded cumulonimbus clouds. Again, flight level 350 and towards somewhere below flight level 100. We have this huge jet stream over here. Then we have some icing conditions over here. So if we, for example, would fly to Vienna Airport, which is right here, as we approach, we have to take into consideration the turbulence below flight level 160 towards somewhere below flight level 100, and the possible icing below flight level 160 and somewhere below flight level 100. Okay. Then there are some other symbols on this chart. For example, this indicates the Tropopause height. That's the, we'll talk about that later. And this symbol indicates the height of the pressure system and what kind of pressure system it is. Now, I mentioned Tropopause, and Tropopause is the transition between the troposphere in which we live and the stratosphere. Okay. Now, if you're flying, you're likely to cross the troposphere sometime. Okay. Sometimes it's going to be very low, sometimes it's going to be very high that you don't even cross it, but it might happen. And why is the Tropopause important to take into consideration when flying? Well, near this area there's a large variation in wind and temperature, okay? And what this means is that the weather is pretty unstable and will affect your flight, and you have to be careful in this region. Things you might encounter are wind shear and turbulence, for example. So if you notice that you're crossing the Tropopause layer, you have to take into consideration that you might experience wind shear or turbulence or other things that affect your flight, and it can be a bit bumpy up there. Okay, so for example, here we know that the Tropopause is at flight level 400. So if you are flying above that flight level and you're descending for an airport right here, for example, you might be crossing it. But for example, here the layer is way too high. Usually in normal airliners you won't cross it. Maybe some business jets. For example, here it's pretty low. Okay, so there's a higher chance that you will cross it. Okay, and this is another chart provided by Simbrief.com flight plan, flying from Chicago to Amsterdam, and you can see that the height differs a lot. You can see this on this chart. Okay, so actually in cruise level we cross it 2 times here, at flight level 350, and then sometime later at flight level 350 again. So it's important to take into consideration. You might want to turn on the seatbelt sign when you're near this Tropopause layer.
So guys, thanks for watching this video here on the Aviation Pro channel. I hope this helped you out and it appealed to you a little bit, because I find meteorology quite interesting and looking at those weather charts, and I always look at the sky and look at those clouds, and I think they're very beautiful. And of course in flying, if you're flying, it's even more beautiful. So thanks for watching. Make sure you head over to patreon.com/aviationpro to support the Aviation Pro channel if you want to. It would be very much appreciated. And make sure you subscribe, comment, like. I try to answer every single comment on my videos. So thanks for watching, and I'll see you next time.